Hello guys, so welcome to another tutorial, and today's tutorial is very interesting and it's very special because in today's tutorial we'll be taking the deployment of OCUDU or OCUDU or SRS RAN a bit more further, because this time we'll be introducing the AI agents into the OCUDU. So the overall idea of this tutorial is to manage and operate your OCUDU RAN stack with the AI agents overall. So starting with the repository that I created, um, this is the basic repository which will go into deep like what is inside the code base. So firstly we'll have a look onto the readme, what readme says. So you can see this OCUDU-AI-Agent-Skills repository is basically built to monitor and operate the OCUDU 5G RAN stack using AI coding agents, and it's built on top of like agent skills, which are basically the standard. You can go here and learn what are agent skills, why they are used, how to start with them, what are the specifications you need to follow and everything. And in our case, we are using this as a standard. And the structure of our repository is, it's not very vast, it's minimal. Like we have the .agents folder inside that. If you go deep, we have the main skill.md file, which is the skill instructions for your AI agent to define, okay, what actions you need to perform when a user asks for something specific. And then we have some scripts and references. The script is to basically collect the matrices via the WebSocket from the OCUDU codebase, and the references are basically to define the JSON matrices along with the field and the description, which we'll have a look. And these are some config parameters which are also defined in the markdown file for the AI agent to understand, to give it more context about, okay, we are talking about these things, what these parameters mean and how you should use them, right? And then we have the setup. It's very minimal, just clone this repository and that's it. That will have a look on the terminal part, and it's a sample configuration file. We'll discuss about it later. And yeah, these are some of the examples that you can ask your AI agent to perform for you. For example, you can ask it how many UIs are connected, or collect some matrices during the ping test or whatever, right? So yeah, if we go into the code base, so this is the main folder in which we have two subfolders, the references and the scripts. And firstly, let's have a look onto the skill.md file. So this is the main agent skill file with instructions for monitoring and operating the OCUDU G0B. And you can see the description. It says you need to monitor, operate, and query a live OCUDU 5G G0B base station via its WebSocket matrices, which are obviously in JSON. And a few more details are written, like when a user asks about the connected UAs, signal quality, CQI, MCS, and few more things, you need to trigger this action. And then we have some prerequisites. Okay, these things should be enabled in the config file, and the matrices should be enabled, which I have mentioned in the README as well. And now this is a overall environment context to the AI agent, like the G0B is running on the host, and the SRS UE is also running on the host, and we are using Open5GS as the core, which is running on the Docker, so that the AI agent can understand, like, okay, what is going on inside it, like, right? And now a few more details about what to do when user asks about to run the G0B and everything, and to perform a ping test, what you should do. And then these get connection details, and how you should connect the matrices, from where, what is the URL, and like this is the overall WebSocket with the port from where you need to fetch the JSON matrices. So this is like the overall context, like, okay, now your AI agent is grabbing the things. Yeah, it's trying to digest what is going on and how and when it should trigger the things. Okay, now we can go back, and now we can go to the references part. So this is another markdown file. What it basically do is, like, it's a basic YAML configuration parameter guide, where it is defining all the parameters that are being used in the OCUDU code base, like which parameter means what thing. For example, this DLERFCN, this is it determines the central frequency, so that this AI agent can have more context about each parameter. If somebody asks about the tracking area code, it knows where to go for the tag, it knows where to go for the PCI. If somebody asks about a physical cell identifier or anything, right, which is defined in the code base. So we are defining every single parameters, and this one is important because we need to enable it manually. It is not by default in the SRS RAN or the OCUDU config file. So you need to enable the matrices so that you can get the JSON matrices over the WebSocket. And to get them over the WebSocket, you need to also enable the remote control access, and you can just put it like localhost or whatever you want to if you're using it remotely. And then these logging parameters and a few more things. Similarly, we have the matrices schema.md file, which is defining all the matrices fields and the description, like what PCI means, what this average latency means. Similarly, we have for UE, like what this DLRI means. So all these parameters are being defined along with their type, either it's float or integer, what is the unit and everything, right, to give it more and more context. After that, we have the scripts folder, where we have this Python file, which is basically, in simple terms, it's a WebSocket client that grabs matrices snapshots based on the OCUDU own what the JSON matrices it provides. So it is basically used to capture all the matrices from the OCUDU code base, and then AI agent can fetch the details from this, and it can, respond from concluding everything from these files and respond to the user. Okay, this is the thing that I am getting, right? So yeah, this is all about the whole, like, the code base, additional code base of AI agent skills. Obviously, we'll be using it with the OCUDU code base, which we'll have a look on the terminal. So now let's move to our terminal part. This is my VM on which we are going to do all this testing. So the first step should be to clone this repository. Now I can simply copy this and git clone. That's it. So now we can go inside this repo and oops, yeah, we can do tree as well. I see. Now you can see we have the whole repository here. We have the skill.md, we have the references and the script files available here. Now what we want to do is we can simply run Claude. And before that, I can show you that I don't have any G-Node-B or UE running. So we will ask the AI agent to perform all the operations like running the G-Node-B, the UE, performing the ping test and everything by itself. However, I am using like the Open5GS is running on my system. So yeah, that's an exception, I would say. But yeah, you can see Docker PS. We have the Open5GS running over here. You can also see the logs. Right, so these are some logs that I've tested in the past. Now let's use Claude. All right, I trust it. Yeah. Okay, now, oh wow, we have the voice mode as well. Let's leave it for now. And what we can do is, I want to ask, can you check if OCU is running on my system or not? Okay, let's see what it had to deliver. All right, let's give the permissions. Okay, it says no OCUDU is running on my system. So yeah, it is asking, would you like help starting it or checking how to install, configure it? I will say, sure, can you just start the G-Node-B? And let's see. Interesting. So it says the G-Node-B started successfully. That's good. So let's check it out. I can create new terminal. I will do it later. And I can just do this and this now. All right, now you can see the G-Node-B is running, which is pretty cool. I mean, the AI agent did it everything by itself, so I was not expecting it. Now let's start the UE as well, and let's have a look. Sure, please start the UE as well. Oh wow, the UE is up and running, and we can check here as well. Wow, you can see the SRS UE is also running, G-Node-B is also running, and the core is also running, and the full stack is up. Okay, I think it is not lying to us. And we can obviously see the logs at this location, which if we want to see, we can manually see by typing it in the terminal. Otherwise, we can make sure if things are working or not. And just quit from it. And if I do Docker PS, and if I print the logs of it, and you can see, hopefully the UE and the G-Node-B, the session is complete. Along with that, we can also have a look on the G-Node-B logs. Okay. Okay, there is some issue. That's fine. And no, it should be, yeah, leave it. Okay, so now we can ask the AI agent to analyze our end-to-end setup and see how many UIs are connected to my G-Node-B. Okay, it says one UI is connected, and it shows all the fields and values, the RNTI, CQI, the downlink and uplink bitrate. Obviously it's 0 because we are not performing any ping test. So to make things a bit more interesting, what we can do is, yeah, would you like to run a ping test? Sure. So we would like to have a ping test. can you perform, and also while performing the ping test I want to see the throughput as well, and show the all right, let's see. Okay, it is pinging, you can see, and we can see the packet loss and the uplink bitrate, downlink bitrate. So obviously it's not too high because you're just performing the ping test, but it's very interesting. Like it's performing the ping test for us, and the ping test is also successful as well. It's not like it's stuck in anywhere in between. It's successful, and we can see the bitrate as well going up and down. Yeah, it says okay, ping. Yeah. Now we're not in a mood to run the iPerf. We'll see that later. Now what we can do is we can also check if the UE is registered in the 5G core or not. However, we have checked that, but we can make sure if this agent can verify that or not. Nice. And it shows everything: registration, the SUPI, DNN, okay, SNSS AI, and it also shows the assigned IP, and it is performing well. Now, what I can ask him is maybe about the signal quality of the connected UE. Okay. Oh wow. Now we can see all these beautiful matrices with all the details, the mattress, its value, and the nodes, which is interesting. And now I can hear my server crying, maybe because of the CPU and memory usage. So why not to ask that from the agent? What is the CPU and memory usage of the G0B? And you can see here as well. Nice. So it shows the OS level resource usage as well. The CPU is 191% of its limit. The memory is 2.5 gigs. So, and we can see the CPU load on specific threads as well, which is very nice. Okay. And the high CPU on this is expected. Yeah, it's good. I mean, I can hear that sound from my server. So yeah, there is some load on the system as well. I'm pretty sure about it. And we can also ask it if there are any issues in the HARQ, like are there any failures or something? Most probably there should not be any issue, but yeah, you can see the status, everything is fine. And now what else we can think about is maybe to collect some matrices and give a full health report of the G0B. How does that sound? Let's see. Okay. Cool. Oh, that's too much, I guess. But wow, it created very nice representable data with all the details and everything. Let's have a look. Yeah, it shows the system resources. Okay. Now we have the core network connectivity, the NGAP thing. Success rate, excellent. RRC connections, excellent. And we have connected UEs, one. Everything is okay. And signal quality also, you can see the SNR and RSRP values and everything. Yeah, it's awesome. Nice. What else? Maybe we can ask him about the modulation schemes which are active right now. Okay. QPSK only, nothing on uplink. With MCS 0. All right. Yeah, that's true. What we can do is we can also have a look on the logs of G0B. Can you show us the G0B logs? I don't know, there is some issue. Permission denied. Okay, let's proceed. Oh, the graph looks very interesting. I don't know what's going on, but it looks good. Very colorful. Nice. Okay, they are not being captured. All right, it's fine. I don't expect it everything to perform. So one last thing we can do is, let's see if it can do this or not. So we are asking about collect the baseline matrices and then run a ping test from the UE and then collect the matrices again and then compare the before and after results. Let's see. Okay, now you can see the baseline versus ping comparison. Okay, let's look from the beginning. All right, so system resources, baseline, nah, nothing. But during the ping test, obviously it cannot stop the G0B, so it should be same. We do not have much data about the baseline, so it's fine. And then about the scheduler, we can see some differences. No, not much. Obviously, it will not make difference if you ping. Then DU high, DU low processing. Okay, and we can see some threads percentage. I mean the utilization maybe. It is increased a bit. Yeah, okay, that's good. And here we have the summary as well, that yeah, this UEUL exec hash 0 woke up from 0 to 1.1%, so that's a significant upgrade in that. And yeah, so overall I would say it's performing well, and it's really good. It's not only able to read the matrices and utilize them in a very good way to perform all the actions, it can also operate the G0B, the UE, the ping test, which is pretty cool, I would say. And maybe we can ask it to shut down the G0B and the UE. Can you turn off because it's running? Let's see if it can do it or not. It tried, but it failed. Let's try again. Oh, it is able to kill the UE thread. And not sure about G0B. Okay, it stopped the UE and now it's trying to stop the G0B. And yeah, it is able to do that. Bother shut down cleanly. Great. Yeah, I would like to stop. Sure. Okay. Now the full stack is shut down and we cannot see any thread of anything. All right, perfect. So, and yeah, maybe we can say it's a very initial pre-phase of AI ran with OCUDU. Maybe we can see more use cases in future around it, what it is more capable of doing. So let's see. Yeah, that's pretty much about the video, and see you in the next one.